Today we'll talk about Ferris wheels. Here's a diagram of a Ferris wheel. It shows you most everything we need to figure out. The center of the circle is the axis of rotation. The radius is the amplitude. The diameter, well, that's twice the radius. It helps you with maximum and minimum. The distance off the ground, that helps you with minimum. And we'll have other things here as well. So again, to reiterate, the amplitude is radius. The axis of rotation is the center of the circle. That is the maximum point minus the radius, or the minimum plus the radius. The period length is one full rotation. The period length can also be found by the circumference divided by the speed. And the horizontal shift is essentially equal to the time of arrival at the maximum, the first maximum. Now, there are several different horizontal shifts we could use. We could use the first maximum, the second maximum, the third maximum. We will probably use the first maximum. The first time the graph hits the maximum. So let's try one out. Suppose the Ferris wheel you're on has a diameter of 50 meters. The center is 30 meters off the ground, and one full rotation takes 20 seconds. If you reach the highest point on the wheel 8 seconds after the ride starts, write an equation that would model the height off the ground for X seconds after the ride began. So a couple of the things we have here. We have diameter. Diameter is 50 meters, which means the radius is 25. The center is 30 meters off the ground, and that tells us our axis of rotation is 30. Again, here amplitude is radius, so this tells us our amplitude. It says one full rotation. One full rotation is 20 seconds. That's a very fast Ferris wheel. And it says if you reach the highest point is considered the maximum. The maximum happens at 8 seconds. This is the horizontal phase shift. This here is the phase shift to the right. So if I was to take this information and draw a graph, I would have my axis of rotation at 30 meters. My maximum point would be 55 because that's 25 meters above 30. My minimum point would be at 5. And then we have this phase shift to the right 8. And then this here is our period length. One full rotation is the period length. So we need to go out plus 20. So this is going to be 28. And then we divide this section into 4 pieces. So half of 20 is 10, so this would be 18. And then 1/4 of 20 is 5, so this would be 13 and then 23. And now we plot our points, and let's see what that looks like. So here's the graph, just like what I drew a second ago. Maximum at 8, 13 is on the axis, 8 is a minimum, 23 is on the axis, and 28 is returning to that maximum point. When you connect the dots, you have the cosine curve. Now, we must identify A, B, C, and D. So we can write an equation. And we're going to write the equation and fill in blanks. Y equals A cosine B x minus C plus D. Well, if we use the information we have, A is the amplitude, and amplitude we found was 25, so 25 goes first. D is the axis we found is 30. C is the horizontal phase shift. The horizontal phase shift, I call it the HPS, goes over 8. So C is equal to 8. And then B is the period length, or B uses the period length. B is 2 pi divided by period length. So 2 pi divided by 20 is equal to pi over 10, because those turn into a 1. So B is pi over 10. And now we have our equation that we wrote to model this Ferris wheel. Right here. Okay, ladies and gentlemen, that's Ferris wheels.